I had a request on section 1.5, probably one of the easier sections in this book as far as the types of problems are concerned, but it's one of those sections that can kill people's answers because they don't know how to express the answer. And so, because most people who can solve a linear equation can solve a linear inequality, the only difference between solving a linear equation and an inequality is that the inequality, you have to switch the inequality symbol around when you multiply or divide by a negative number. So that's when the symbol has to be switched. In class, I showed my class why you have to do that. On these kind of videos, I don't spend the time of showing you why the things are. I was showing more of how the things are. So, but anyway, when you're doing inequality, your answers are going to be in this form when you're done with your types of problems. You're going to say x is greater than a, x is less than a, or x is in between a and b. So every one of these problems in my examples will be one of these types of problems. So you're going to end up with one of these three right here. And then you have to say the interval notation. The interval notation kind of goes along with the graph. So when you're saying x is greater than a, you're saying you're starting at a, but not including it, and you go all the way to infinity. So the graph of that would look like this. So starting at a and going to infinity. Now, some of you guys are probably used to the open circle. There's a little circle there instead of the parentheses. This is the new way of doing it. So if you wanted to use the open circle, that's the way you've always done it. That's okay. You can still use the open circle. Just in my classes, I use the parentheses because that is becoming more standard than what it used to be. When you solve it, you get x is less than b. You get negative infinity to b, so because everything on the left side of b, and it looks like this. It's very similar. Now, if it said greater than or equal to or less than or equal to, the only difference between the interval notations and the graphs is the parentheses turns into something else. They can turn into brackets, except on the infinity symbols. They stay parentheses. But if this said x is greater than or equal to a, this has a bracket, and so does that one. So now you kind of know why we're migrating to this kind of notation instead of the filled-in circles or the closed-in circles, is because there's a connection between the graph and the interval notation. Yes, the parentheses goes with parentheses, and this had a bracket, so would this one. If this one here gets a bracket on the B, so will this one. So that it keeps that a little bit more consistent there. And when you say like this, you're saying x is between A and B. So your answer will look something like this. By the way, that would be example 4 that I have listed right here. So when I get to that. So what you're basically saying here is all the numbers between these two numbers, A and B. And since they have no brackets, I don't include the A and B. If I wanted to include them, I'd have less than or equal to, less than or equal to, and then these would get brackets, and so will this one. So, but anyway, these are the three possible answers you could have in your homework. So now, in example 1, it's a very simple problem. You solve it, like I said, you solve it just like you solve an equation. You move the 3 over, you divide by 2. Except if you ever multiply divide by a negative number, you have to switch the symbol around. So in this particular case, you subtract 3. You get 2x less than 6 minus 3, which is 3. Then you divide by 2. And then x is less than 3/2. And what that is basically saying is the second one right here. It says it's x is less than that, so it's everything to the left of 3/2. So in your interval, it'd be at 3/2 and everything to the left. And it gets a parentheses. That's your graph. Now your interval notation would be negative infinity up to 3/2 with the parentheses on that end. And so basically, since any number that's on the left side of 3/2, like 1, 0, -1 would be solutions, and all the numbers in between. So all those numbers would be solutions. But you take a number over here on the right side, like 5, and you try to put 5 back in here, it would not work because it's not in the interval. It's not on the graph either. So that's what you're doing. So the difference between equations and inequalities, the main difference is the number of solutions you're going to get. On equations, you're going to get a finite number of answers. You can count them. You can actually count them. Whereas on the infinite, it becomes an interval of numbers. So in a way, you can think of it as an infinite number of solutions. So that's example 1. So this is how you'd write the answer. You'd want the interval, and you'd want the graph. Now, example 2, okay, same setup, but I made it a little different because I want to put a negative in the front because I want to show you what happens when you divide by a negative number. So here you add 1, and you get negative 3x is less than or equal to 8 plus 1, which is 9. You divide by negative 3, and 9 divided by negative 3 is negative 3. And you switch the inequality symbol the other direction. It changes magnitude. Again, in class, I did tell everybody why you have to switch the inequality symbol around. And if you don't know why, that's fine. You just have to remember to do that. Then on the graph of that, well, you find negative 3 on the number line. If you notice, pretty much all my graphs, I do the same kind of thing, everything. I just kind of put a point in the middle and label the point where that endpoint tells me to pay, so it's scaled any way I want to do it anyway. And I shed everything to the right. And if you remember from a while ago what I said, if it's to the right and you include it, you need a bracket. And always the bracket or the parentheses always faces the direction you're going. So we're talking about the first one here. So it's starting at negative 3 and it goes to infinity. And that's what this graph kind of looks like. So in this particular case, it's bracket negative 3 to infinity. And that's the answer to example 2. We'll need this one and that one. In your homework, they also mentioned something called set notation. I'm not going to teach you that. We don't need to bother with the set notation. All we're going to do is the interval notation and the graph. So if you want to know the set notation, you either stop by my office sometime or read the book. So we can always read math books. And so example 3, all right? Now this is the same idea, except now we have fractions. This is probably the type of problem that's causing the most grief of students because they have fractions. Well, if you don't like fractions, well, get rid of them. That's all you do is just get rid of the fractions. So you look at the fractions, you got 1/2 and 1/3. To get rid of them, I just multiply both sides by 6. So if I multiply both sides by 6, because that's the LCD, well, the 6 cancels with that. That's 3 times, so it's going to be 3 times 2x minus 3. So in other words, 6 times a half. Half of 6 is 3. That's all I really did. And over here, 1/3 of 6 is 2, so this is 2x. So then you get 3x times 2. The 2x times 3 is 6x minus 9 distributed to 3. And that's greater than 2x. Actually, not equal. Should make that a greater than. Then subtract the 2x over here, and that's 4x. And then add the 9 over here. So basically, I just played musical chairs with these two terms right here. I brought the 2x over here, brought the negative 9 over there. And then divide by 4. And so x is greater than 9/4. So as you can tell, sometimes the answers don't look very pretty. But it's anything bigger than 9/4, which is 2 1/4, which we don't want to really write it that way, but that's what it is, 2 1/4. So anything bigger than that's fine. Like 2 1/2 is fine, 2 7/8 is fine, but the number like 2 would not work. So what you're doing is you're finding the numbers that satisfy the original problem. So the interval would be 9/4, comma, infinity, because it's in this form here. X is greater than a, so it's this one. So it's 9/4 to infinity. So you have parentheses, 9/4. Whoops, I already did that one. I need the graph. So again, notice what I did. I put 9/4 right there in the middle. So, and then you shade to the right and you put the parentheses. So that's example 3. In example 4, okay, the first thing I see is another fraction. So I put that fraction on purpose because I know students have trouble with that. So the first thing I'm going to do is I'm going to multiply both sides by 2. Everything by 2. Look what happens. 2 times 5 is 10, less than. 2 times 3 is 6. 2 times 1/2 is 1, so it's negative 1x. And then 2 times 11 is 22. So I multiplied straight across the board with 2. And all that serves the purpose of is getting rid of the 1/2. That's the reason I decided to do that. If it wasn't for the fraction of 1/2, I would probably just start moving numbers to the other side, trying to isolate the x, and that's what I'm going to do now. So here, I'm going to subtract 6 from everything. 10 minus 6 is 4, and the 6's cancel, so it's 10. 4 is less than negative 1x, and that's less than 16. Okay, so then you got 4 less than negative 1x is less than 16. X is almost isolated, but it's still got that negative 1. So what we're going to do is divide both sides by negative 1. Oh, actually, all three things by negative 1. This is what you call a compound statement. Basically, they're basically telling you two things. This number is in between the 5 and the 11. So what you're trying to do is figure out what solution between what two numbers makes that happen. So that's what this is all about. You're basically saying your solution is somewhere between A and B. So this is what we call a segment of answers. This is what we call rays of answers. This is a ray. This is a ray. And this is a connection between here and geometry, actually. So you divide by negative 1. So 4 divided by negative 1 is 4. This is x, and this is 16, but negative. But you remember you have to switch the inequality symbol around. So in this case, they're telling me that x is between negative 16 and positive 4. But the magnitude of the numbers have been reversed. So you still write it the same way. You're between negative 16 and 4. So notice the smallest number is on the left and the biggest number is on the right. And then when you do the graph, I'm not going to do the graph, I'm out of room anyway, but you go from negative 16 to 4. You have to put negative 16 right here, 4 there, and you would shade between them and put the parentheses on each end because there are no equal to. So I think I've done about every situation that you could possibly see. But like I said, I had a couple people ask me about 1.5, and I think the main reason is probably not the math so much. It's probably how to write the answer. Maybe a little bit of the fractions. I know some people are probably having a little bit of trouble with dealing with fractions. You've always had trouble with fractions. A lot of students do. It's just I don't deal with them. If I don't like fractions, I get rid of them. So what I do is I multiply by the least common denominator. That very first step, they're gone. So if you don't like something, make it go away. And the only way you're going to make a fraction go away is if you multiply by the LCD across the board. And then you don't have to deal with them so much. So anyway, that's 1.5. And thanks for listening.